we're going to talk about some strange cell behavior. This is normal cell tissue, about to proliferate. Normal tissues primarily use cellular respiration to create energy for their cells. Cellular respiration has three main steps: glycolysis, the citric acid cycle, and oxidative phosphorylation. The diagram shows how normal tissue may go about creating energy in the presence of oxygen or in the absence of oxygen. The differentiated tissue, or non-proliferating tissue, creates energy in both hypoxic or normoxic states. In the presence of oxygen, glucose is metabolized to 2 molecules of pyruvate in the process of glycolysis. Then, pyruvate oxidation occurs in the mitochondria. Inside the mitochondria, acetyl-CoA is produced and begins the citric acid cycle, also known as the Krebs cycle. At this point, glucose has been broken down into carbon dioxide. The creation of lactate during anaerobic glycolysis repeats glycolysis by spitting out NAD+ at the end of the reaction. However, there is such a dismal ATP production at the end of the reaction that you might wonder if it's even worth it at all. This is where the Warburg... This is malignant cell tissue. Malignant cell tissue is a little bit different. In 1924, Nobel laureate Otto Heinrich Warburg surmised what came to be known as the Warburg hypothesis, or the Warburg effect. Basically, even when presented with ideal environments, that is, environments with normal oxygen conditions, Warburg saw that cancer cells usually convert glucose into lactate, utilizing the process of aerobic glycolysis, instead of oxidative. In fact, sometimes even normal tissues practice this behavior.
Are you talking to me?
Yes, I am talking to you. Cancer cells are truly unique, and no, not in the good way. Cancer cells are focused primarily on proliferation and survival. Okay, so here's a question. Why do tumor cells choose biomass production over energy production? And why does oxygen, or lack of it, seem to have no influence on the decision of these cancer cells? Warburg owed this to a dysfunctional mitochondria, and went on to hypothesize this as the main cause of cancer. In the 1970s, Ephraim Racker coined this as the Warburg effect, and decided that its origins could stem from imbalances in intracellular pH or even defects in membrane-bound ion channel activity. Eventually, it was discovered that deviant growth factor signaling is a prevalent event prior to onset of tumorigenesis. Current studies have shown that successful tumorigenesis requires the Warburg effect, therefore confirming Warburg's theory. In his own words, Warburg said, "The prime cause of cancer is the replacement of the respiration of oxygen in normal body cells by a fermentation of sugar."